All right. Hello, pre-calc students. I'm going over problems 9, 10, 11, 12, 13, and 14 right now. So we need to find two polar coordinates equivalent to each set of rectangular coordinates. Round to the hundredth place in reading when needed. We're going to do the odd numbers in radians and the even numbers in degrees. All right. And so I don't have to switch in between my calculator. I'm going to first do all the odd numbers and then do the even numbers. And here, if I have a point, so I have my point 7, 10. So I have my point 7, 10, which means that I have a horizontal component of 7, vertical component of 10. If this is the origin, I'll have my horizontal component of 7 and my vertical component of 10. And to find r and theta, so to get to my polar coordinates, I need to find r, the distance between the 2 points, and theta, the angle of the line from the origin to the point. And using right triangle trigonometry, we see that r is the hypotenuse of the right triangle, theta is the reference angle of the right triangle. So we can derive our polar equations that we're going to need to use. R squared is going to be equal to x squared plus y squared. That comes directly from the Pythagorean theorem. Because 7 is the x component of the right triangle, 10 is the y component of the right triangle. And so r squared, knowing that the leg of a right triangle squared plus the other leg of right triangle squared is equal to the hypotenuse squared, we say that r squared is equal to x squared plus y squared. We also have our secondary version of this formula, which is we just take the square root of each side, so we know that r is equal to the square root of x squared plus y squared. All right. Okay, so that's one formula, and then the other formula to find theta is we have 10, we have 7. The tangent of theta is y over x. So because the tangent of theta is y over x, we can find theta by taking the inverse tangent of each side. So theta is equal to the inverse tangent of y over x. So now that we've gone over all our formulas, let's solve r, let's solve for r, and let's solve for theta. So r is equal to the square root of x squared plus y squared. So r is equal to the square root of 7 squared plus 10 squared. So we can get out our trusty calculator to double check our answer is correct. This should be the square root of 149. So we find the square root of 10 squared plus 7 squared. And you should get a value of about 12.2. And that makes sense because if 12 squared is 144, 10 squared plus 7 squared is 149. And so 12.2 is just a little bit more than... So 12.2 is a little bit more than 12, and 149 is just a little bit more than 144. So that intuitively makes sense as the square root of 149. So r is equal to approximately equal to 12.21. Let's round up. R is approximately equal to 12.21. Theta is going to be equal to the inverse tangent of y over x. It's going to be the inverse tangent of 10 over 7. So we just make sure we go to radian mode. We go to mode, radian mode, and we find the inverse tangent of 10 over 7. So that's going to be 0.96 radians. So theta is equal to 0.96 radians. So we're going to have an R value of 12.21 and 0.96 radians. So we can have it one polar coordinate could be, let's do blue for my answer. We can have an R value of 12.21 and a theta value of 0.96 radians. All right, but we need to find a second polar coordinate. And one way to find a second polar coordinate is just to add 2 pi to our radian value. So we can do 0.96 plus 2 pi. That's going to be 7.24. So second polar coordinate that's going to be have equivalent polar coordinate could be at 12.21 and then at 7.24 radians. 7.24 radians. So these are our polar coordinates right here. All right. With 10, we can look at finding polar coordinates for different quadrants and also different ways of representing polar coordinates. So r squared is going to be relatively simple. R squared is going to be equal to x squared plus y squared. All right, so it's going to be equal to negative 13 and 4. So it's going to be equal to the square root. Well, so r squared is going to be equal to 13 squared plus 4 squared. So if r squared is going to be equal to 13 squared plus 4 squared, r is going to be equal to the square root of negative 13 squared, make sure that's in parentheses, plus 4 squared. So in our calculator, we will do the square root of, let's keep this in parentheses, negative 13 squared plus 4 squared. So that's going to, that should be so that should be 13.6. Find the square root of 185. Yeah, it's also 13.6. So r is equal to approximately equal to 13.6. R is approximately equal to 13.6. All right, and then we need to find theta. And now this coordinate is going to be in quadrant 2 because x is negative and y is positive. So when x is negative and y is positive, that puts us in quadrant 2. So when we find the inverse tangent of 4 over negative 13, so when we find the inverse tangent of 4 over negative 13, and remember this is an even number, so I'm going to switch to degree mode because it asks to do odd numbers in radians, even numbers in degrees. We're going to find the inverse tangent of 4 over negative 13. All right, so that's going to be negative 17 degrees. All right, so our calculator output when we find when we find inverse tangent 4 over negative 13, our calculator output is going to be equal to negative 17 degrees. Negative 17.1 degrees. But that's not our angle because we are in quadrant 2. And if you find an angle that is, or if you know that your angle is in quadrant 2, and we know this because our x is negative and our y is positive, then we have to adjust this angle to a quadrant 2 angle. And we do this by adding 180 to our value. Because 180 minus 17.1 is going to give us our reference angle. Just as a quick illustration, we make this xy axis a little bit bigger. If you have a 17.1 angle here, remember that's negative 17.1 because we rotate counterclockwise. The reference angle in quadrant 2 would be this angle right here, and that angle is going to be 180 minus 17.1. So to get theta, we get theta is equal to 180 minus 17.1. So we just, what we do here is we add 180 to this 17.1 angle right there, and our degree value is going to be 162. So theta is going to be equal to 162.9 degrees. So 162.9 degrees is our theta value. So we're going to have a value, one polar coordinate of 13.6. That's r. Theta could be 162.9. All right. Another value we could do is if we added a 180 to our polar coordinate, that we can make the r value negative. So if we add 180 to 162.9, that gives us 342 degrees. So if we add 180, we can make our r value negative. So we could have another polar coordinate of negative 13.6, and then a theta value of 342.9 degrees. And we got 342.9 degrees by adding 180 degrees. So notice, if you can find equivalent polar coordinate by changing the sign of the r value and then adding 180 degrees to your theta value. And if you can, try conceptualizing that. All right. For 11, okay, we're going to be in odds, so r is going to be equal to r squared is going to be equal to negative 6 squared plus negative 12 squared. All right, so that means negative 6 squared is 36, negative 12 squared is 144. 144 plus 36 is 180. So if r squared is going to be equal to 36 plus 144, that means r squared is equal to 180, which means r can be accurately described as the square root of 180. Okay? All right? So, this is going to be a quadrant 3 angle. So we can find theta. So our calculator output, remember this is x when the x coordinate is negative and the y coordinate is negative. This puts us in quadrant 3. So this value is negative. This value is negative, so that puts us in quadrant 3. All right. So our calculator output is going to be the inverse tangent of negative 12 over 6 over negative 6. So we find in radian mode the inverse tangent of negative 12 divided by negative 6. And that's going to be equal to 1.107. But what we have to do is that our calculator output, because we are in quadrant 3, because we are in quadrant 3, we have to add pi to calculated output. All right, remember, in quadrant 2 or 3, if we're in degree mode, we add 180. In radian mode, we add pi, because pi radians is equivalent to 180 degrees. So we find the inverse tangent of negative 12 over negative 6, that's 1.01. We add pi, and that's going to give us 4.23. So our angle is going to be 1.107 plus pi. So theta is equal to 1.107 plus pi, which is going to be equal to 4.23. So we could have an R value of, so for polar coordinates, now that we found theta values, we can have two polar coordinates could be the square root of 180 and 4.23, or negative the square root of 180 and 1.107. 1.107. So these are our two polar coordinates. All right, 12 is going to be in degree mode. And we can do this quickly because this is in quadrant 1. Yeah. This is in quadrant 1, and when you're in quadrant 1, the calculator output for tangent is your actual value. So R is going to be equal to the square root of 2 squared plus root 2 squared. Yes. Yes. And so that's going to be, in our calculator, we take the square root of 2 squared plus, well, the root 2 squared is just 2. So in fact, this is the square root. 2 squared is 4, and root 2 squared is 2. So we're taking the square root of 6, really. So we find the square root of 6, which is going to be 2.44. So R is equal to 2.44. All right, now theta, because this is in quadrant 1, theta is equal to our calculator output. This is an even number, so we're in degrees. So I take my calculator. Oh, wrong application. I take my calculator, go to mode, go to from radian to degree, and then I find my inverse tangent of the square root of 2 divided by 2. And that should give me 35.26 degrees. Right? So theta is equal to 35.26 degrees. So one polar coordinate that I could have here is an R value of 2.44 and a theta value of 35.26 degrees. But let's try. You could also make your R value negative and add 180. So you could also have an R value of negative 2.44 and then change our theta value by 180, add 180 here. And have a theta value of 215.26 degrees. Okay, that was 12. Alright, 2 more before we're done with the section. Alright, 13 is 1, negative 1. This is going to put us in quadrant 4. When x value is positive and y value is negative, that's going to be in quadrant 4, which means that our calculator output for theta doesn't have to change. So r is going to be equal to the square root of 1 squared plus negative 1 squared, which means r is going to be equal to the square root of 2. 1 plus 1 squared is 1, negative 1 squared is 1, 1 plus 1 is 2, square root of 2. So r is equal to the square root of 2. Theta is going to be equal to the inverse tangent of negative 1 over 1, which is going to be equal to negative 1. So theta is going to be equal to the inverse tangent of negative 1. Alright, and the inverse tangent of negative 1 should be pi over 4. So this comes from a unit circle, or you could do it in your calculator, but in radian mode, you can find the inverse tangent of negative 1, which is which should be negative pi over 4, and then you find negative pi over 4, you'll realize that's going to be the same value. So that's why, if you have your unit circle memorized, the inverse the tangent of negative pi over 4, or 7 pi over 4, is going to produce a value of negative 1. Okay. So theta is going to be equal to negative pi over 4. So theta is going to be equal to negative pi over 4. Another representation for negative pi over 4 is 7 pi over 4. So our two representations could be our r value is the square root of 2, and our theta value is 7 pi over 4. A second representation could be our r value is minus the square root of 2, and our theta value is, well, if 2 pi equals 8 pi over 4, and pi equals 4 pi over 4, then we could subtract pi and get 3 pi over 4. Negative 2, 3 pi over 4. Alright? So, if we have 8 pi over 4, right? We subtract pi over 4, so we just start at 2 pi, subtract pi over 4, that gives us 7 pi over 4, giving us a value between 0 and 2 pi, a radian value, and then we have square root. If we make our r value negative, we have to go change our angle by 180 degrees, or 2 pi radians. So pi radians is equal to 4 pi over 4. So we subtract 4 pi over 4 from 7 pi, giving us 3 pi over 4. For 14, last one in the section, we're going to have the square root of 3 squared plus 1 squared. So we're going to have r is equal to the square root of 3. Oh, sorry. We're going to have to find the square root of the square root of 3 squared plus 1 squared, which should give us 2. Because the square root of 3 squared is 3, 1 squared is 1, so r is going to be equal to 2. Yes. Yep. Theta is going to be equal to, and this is in quadrant 1, theta is going to be equal to the inverse tangent of 1 over the square root of 3. All right. And just from the unit circle, if the tangent of theta is 1 over the square root of 3, that means just from the unit circle, we know this is going to be at, well, even numbers are degrees. That should be at 30 degrees. So from the unit circle, this is 30 degrees. Okay? So that means we have potential polar coordinates of, if we want to express 2, we have a polar coordinate of 2, 30 degrees. All right. Let's add 360. You could also have a polar coordinate of 2. 360 plus 30 is 390. 390 degrees. Those would be 2 equivalent polar coordinates. All right. So that is all of converting from rectangular coordinates to polar coordinates. Have a great day.